Hello, you're welcome to New Focused Approach to Mathematics Basic 8. In this lesson, we want to look at application of Pythagoras Theorem. This lesson can be found in page 208. We've done the concept of Pythagoras Theorem in a particular video, separate video. We did solve problems involving Pythagoras Theorem and want to further solve questions where we will apply Pythagoras Theorem. And so we'll take few examples and see how it works. Let's say a question like this is given that a quadrilateral ABCD is a trapezium with the distance AB given as 11, AD is 5 centimeters, DC is 8 centimeters, and we want to find the area of this quadrilateral. Okay, where do we bring Pythagoras theorem? Since this is a quadrilateral, it's not a triangle. But in solving this, we have option of using the formula for finding the area of trapezium, but we wouldn't do that because we want to see where we can apply the knowledge of Pythagoras theorem. And so what we can do is, if you try to draw a line straight perpendicular to the base, we create two different areas here. We create, let's say, area A and area B. Area A is a triangle, area B is a rectangle. So if I find the area of the area B and the area of area A, together will give me the entire area of this. Now, knowing that AB is 11, if I decide to put a point here, let me call this particular point E, then between A and E, there could be a distance of 3 centimeters. And the reason being that the whole of this is 8, which means that from E to B is also 8. But then A to B is 11, means there should be 3 here, so that when we add it to the 8, we'll get the entire 11 that we have here. So for us to find the area of the area A here, of course, we need to use the formula half base times height. So area of triangle, area of triangle AED will be equal to half base times height. Okay, and we need to know the height. The height was not given in the question. That is, the height here is not given in the question. But we can use Pythagoras theorem to do that. So we can say h squared plus 3 squared is equals to 5 squared. Making h squared the subject, we have 25 minus 9. I've done some shortcut here. 5 squared will give you 25. 3 squared will give you 9. When you group like terms, we have 25 minus 9. And 25 minus 9 will give you 16. And so to make h the subject, we can say our h is equal to square root of 16, and that h becomes 4. So then we can find the area of the triangle as half base, and the base is 3 times height, and the height is 4. When we simplify this, 2 can divide here 1 and divide here 2, and we have 2 times 3, which is 6 centimeters squared for the area of the first triangle, the triangle labeled A. Now to find the area of the rectangle, okay, area of rectangle B, C, D, E will be equal to length times width, and the length is 8 centimeters, and the width is the height, that is this one, which we got as 4. If I multiply 8 times 4, I have 32, right, centimeter squared. So the total area becomes 6 plus 32, which of course will give us 38 centimeter squared. And that answers the question. That is the application of that. Now let's take another question and see. A ladder of length 15 meters leans against a vertical wall. The distance between the foot F of the wall and the foot T of the ladder is 9 meters. A, we should represent the information on the diagram. B, we should find how high up the ladder reaching the vertical wall. Okay, so let's assume this is our vertical wall and we lean a ladder against it. Okay, and the question says that a ladder of length 15, so I can put 15 meters here, leans against a vertical wall. The distance between the foot F of the wall, so the foot F of the wall, so it means that the foot here, we want to put F here, okay? And so we can also draw the base, I mean the level ground, and then that will make an angle of 90 degrees with the wall. Okay, so if F is the foot of the wall and T is the foot of the ladder, that means I can put T here. And the distance between the foot of the wall and the foot of the ladder is 9 centimeters, sorry, 9 meters. So that is here. We want to find how high the ladder reaches the vertical wall. That means we want to know the length or the height of the wall where the ladder reaches. So I can put H there for that, or I can put X for that. So the diagram here represents our the first part of the question, which is to represent the information on the Venn diagram. Sorry, on the diagram. Okay, so the second part. Now, how do you make X the subject? Of course, we use Pythagoras theorem since the whole diagram creates right angle triangle. So we know that our X squared plus our 9 squared should be equal to 15 squared. And so our S squared, 9 squared is 81, and 15 squared is 225. Okay, now our S squared will be equal to 225 minus 81. So our S squared will be equal to 225 minus 81 will just give us 144. And when you take square root of both sides, you have square root of 144, and root 144 is 12. So I can write my answer X is equals to 12 meters. That means the ladder reaches the wall at the height of 12 meters, and that answers the question. I'm sure these two application questions cannot give you a fair idea as to how we can apply a Pythagoras theorem in solving real life problems. Thanks so much for watching.